So now we're going to start looking at a new type of factoring. Remember, we always start number 1 with greatest common factor. We look for greatest common factor, and then number 2 we look to see what we have remaining. If it's 2 terms, we look for difference of 2 squares, and if it's 3 terms, we look for trinomial factoring. So that's what we've been dealing with. Now there are such things as perfect square trinomials, which are special types of trinomials, and there are even special things as 2 terms that don't look like them, that are harder difference of 2 squares. But in general, this is the factoring that we've been following. The review here is all about greatest common factor. So just to keep in mind what's going on here, number 1, if we look at what's greatest common factor between the two of those, it's just a y. We have 8x minus z left over. Number 2, this is back to the type where we have 2 terms that are actually groups. We have a y plus 1 in common to both of those. That's going to come out as a parentheses group, and that leaves behind the 8x minus z. And number 3, they're almost the same. This is a c minus 2, and this is a 2 minus c. So I'm actually going to change this just a little bit. I'm going to make this the same, but I'm going to pull out a negative in front of the z so that the 2 minus c can become a c minus 2. That makes it its opposite, and that makes the two of them match. Then I'm going to put parentheses around the whole thing and pull out a c minus 2, leaving behind a 17 minus z. So that's a little bit of a review. Now I want to kind of introduce the idea of the opposite, because that happened in number 3. C minus 2 and 2 minus c are opposites. They're opposites because the c and the 2 are both opposite sign. So if I look at something like x plus 4, its opposite is negative x minus 4. If I look at something that's 7 minus y, its opposite is y minus 7. So opposite just means distribute a negative in and let it carry. So if I look at number 4 and I want to state the opposite, its opposite of x minus 2, think about it this way. I could make it negative x plus 2, but the better way to write that is just 2 minus x. Number 5, the opposite of 9 minus x to the 4th is x to the 4th minus 9. Both the x to the 4th and the 9 got opposite signs. And in number 6, because there are 3 terms, I'm just going to distribute a negative. So I get negative 2n plus 6k minus 2. And that's the opposite of that one. This leads us to the idea of 2 and 2 grouping, which I want to go back up to the top and look at what we just did with number 1, greatest common factor. This is part of number 2. 2-term, 3-term. This is now a 4-term. This is the first time we've ever had 4-term factoring. So the 4-term, we're going to look at 2 and 2 grouping as an option. The basis behind 2 and 2 grouping that I want to introduce, I'm kind of swinging back down to the bottom of the first page, is that, sorry, it's taking a second, okay, is that if I were to multiply something like this, a plus b times x plus y, and I foiled that, I would get ax plus ay plus bx plus by. Now, look at what's left. If I saw this and I had to go back to the original, the way to do it is to look at the first 2 and look at the second 2 and see what the first 2 have in common. They have an a in common. So I'd pull the a out, leaving an x plus y. And then in the second 2, I'd pull a b out, which would also leave behind an x plus y. And then because the 2 have an x plus y in common, we're going to pull the x plus y out, leaving behind an a plus b. And now I'm coming back to the top again. So I want you to write that example down and actually work through it just a little slowly to realize that if I start here and I end here, then when I factor, I'm actually going to be starting here and ending here. Let's go to the next page. In number 7, the key behind 2 and 2 factoring is to look to see out of the 4 terms are there two pairs that have something in common? Right now, the way it's written, my first 2 definitely have some things in common, and my second 2 definitely have some things in common. The first 2, what's in common is a 4g, and if I pull out a 4g, I get a 1 minus h. The second 2, if I pull out an h, I get an h minus 1. Okay, those are almost the same thing. They're very, very, very close, but they're not quite identical. In fact, they're opposites. What I'm going to have to do is I'm going to have to change this to a minus just to make sure that they're the same thing. That's really important. So I'm going to keep the first part the same, 4g times 1 minus h. Then I'm going to do a minus, and I'm going to pull a negative out of the h minus 1 to make that a 1 minus h. Still have the h here, but this is now a 1 minus h. Because the 1 minus h's have to be identical in every way. Then we're going to do our greatest common factor factoring with this term and pull the 1 minus h out, which is going to leave behind the 4g minus h. This is a fully factored form because you have 2 binomials multiplied together. No pluses or minuses in between the factors. If I look at number 8, my first and my last 2, my first 2 and my last 2 also share stuff in common. The first 2 have a 3p in common. If I pull that out, I'm leaving behind a 3, not a 3p, a 3 minus q. The second 2, if I pull out a 2n, I'm leaving behind a q minus 3. So it's the same thing. We have to make the we have to make the plus sign become a minus sign. So if I do that, my next step is going to be, say, 3p times 3 minus q, and make this a minus. Now I have 2n times 3 minus q. And now the 3 minus q's are identical, so I'm going to pull the 3 minus q's out, leaving behind the 3p minus 2n. In number 9, if I group my first 2 and my last 2, I have a little bit of a problem. I'm going to actually group by underlining rather than putting parentheses, and you'll see why. If I were to put parentheses, I'd run into a little bit of a problem, which we'll explain here in a bit, but I want you to underline because of this minus sign there. And let's think, what am I going to take out of the first 2? I'm going to take a k, and that's going to leave behind a 3h minus 2. In my second 2, when you see a minus, we want to take out a negative. I'm going to take out a negative 4, and that's going to leave me with a 3h, and I took a negative 4 out of an 8, so that's minus 2. Now the 3h minus 2, those are identical, so that comes out in front, and I'm left behind with a k minus 4. Big thing here, though, is that minus. We're going to see that again in number 10, so I'm going to kind of work with number 10 a little bit. If I group the first 2 with parentheses, here's the problem with a minus being in between those. If I group these with parentheses, and I group these with parentheses, I now have changed the problem because this is now mathematically incorrect. By grouping those with the parentheses, I now make this actually incorrect, and I would have to change that to a negative here, even in this step, even just scribbling into the margins, to make that mathematically correct. Now, something that some people do is this. They'll put grouping symbols here and here, but then you've actually just changed that into 2 binomials multiplied together, and that's not correct either. So what I'd recommend is just doing an underline. That way we can look to see in the underline what's going to get pulled out. I pull out a u, and I get a u minus 3v. And if I pull out a negative 6, and I get a w, and then I get a u minus 3v as well. And those u minus 3v's, those are identical. Oops, sorry. So that comes out in front as u minus 3v, parentheses, always put parentheses, and then a u minus 6w is left behind. Moving on, let's go to number 11. If I look at the way this is done, my first 2, oops, I got a minus, so let's do an underline. Let's go underline, underline. I have an a squared and a b squared plus 2. And then I have a negative 2a, and I'm left behind with a b squared plus 2. The one question that comes up is, do these things I'm underlining now, do those have to be perfectly identical? And the answer is yes, they do. Otherwise the show's over, and you can't do this kind of factoring. So anyway, if I pull this out, I have a squared minus 2a and b squared plus 2. And now you're going to hate me, because if I look at this and look at what's left, this actually could have had an a taken out. Now you could take it out here, but what I really want you to do, and what you really should be doing, I know, we're erasing the whole thing, is going back and looking at the original one, which I failed to do. I failed to notice that there was a greatest common factor within the whole thing. It's easy to notice that when you get in this habit of kind of doing the same types of problems over and over again, forgetting that you do a greatest common factor first. So I do want you to try this with the greatest common factor first. We're going to have an a b squared plus 2a minus 2b squared minus 4. And then if I do my underlining with this and this, I can still take something out. So I've got an a parentheses, then I'm going to take out an a here, and I have a b squared plus 2 minus, and I'm going to take out a 2, and I have a b squared plus 2. And then when I pull out this whole underlined area apart, I take a b plus 2 out, and I have an a minus 2 left, and I still have the a out in front. So that's the proper factored form. That's fully factored. And that reminds us we do need to check for a greatest common factor. Number 12 is an example of a descending order polynomial. I know those can take an n squared out, and these can take a 4 out. No greatest common factor. So let's look at the parts. I can take the greatest common factor out of that part, leave behind an n plus 2, and then I can take a negative 4 out and leave behind an n plus 2. And then finally, when I take out a I can take out an n plus 2, and that leaves behind an n squared minus 4. Now here we do have to check that what we have left we can't factor further, and we can factor that further. That's a difference of 2 squares. So I have n plus 2 times n plus 2 n minus 2. And it is proper to group the n plus 2's together as an n plus 2 quantity squared and then an n minus 2. That's considered the proper way to express it. Number 13, if I look at this example, one of the things with 13 is that my first two don't have anything in common now. So I might have to reshuffle the order a little bit. Maybe 7cw minus 7w squared, then plus 3c minus 3w. That way my first two have something in common, and my last two have something in common. My first two have a 7w in common with a c minus w, and then these have a plus 3 with a c minus w. Then I pull the c minus w out, and what's left is a 7w plus 3. For number 14, there's no greatest common factor, but these two have a 49 and these two have an m squared, so if I take a 49 out of the first two, I get a 1 minus m squared, and if I take a plus m squared out of, m to the fourth out of the second two, I get it 1 minus m squared. The 1 minus m squareds are in common, so that comes out with a 49 plus m to the fourth left. Now, the 1 minus m squared is a difference of 2 squares, so that's going to factor into 1 minus m and 1 plus m, leaving, and then the 49 plus m to the fourth can't factor because it's not a minus sign. Okay, that's enough with that. Now, we're going to practice one more time with the harder difference of 2 squares. This is still dots. This is still a squared minus b squared, or I'd like to think about it as box squared minus triangle squared equaling box minus triangle and box plus triangle. Remember that if I look at 15, this is actually now 2-term factoring. If I go back up to the very top, this is at one of the 2 terms. This isn't 4-term like before. Looks like 4-term or 3-term, but it's not. It's 2-term. Here's one term and here's another, and they're perfect squares. The way we dealt with that is we do big parentheses with a plus minus. And I look at my first group, and it's an x plus y. in parentheses. And I look at my next group and it's an x plus y in parentheses. And then the square root of 36z squared, that is a 6z, and this is a 6z. I'm going to write that one more time, a little bit cleaned up. X plus y plus 6z, and x plus y minus 6z. Number 16. This is where it's really important with this difference of two squares to use giant parentheses, because otherwise we're going to mess some signs up. If I do my plus minus, and then I look at what the first one is, the square root of 4b squared is 2b, and this is 2b. And this group will just be a b minus c in parentheses, and this is a b minus c in parentheses. Now I'm going to kind of clean this up. I have 2b plus b minus c, and then I have 2b minus b plus c. Then I have some like terms, so I can add. I have 3b minus c, and then I have b plus c. Here we've got two groups. We'd had this before. So big parentheses with a plus minus. And then we're going to build the group here. The first one is an x plus 3, so I'm going to put that in both spots. And my second one is an x plus 4y. That was a difference of two squares because they were both being squared. And now they're not. Then I'm going to sort of drop the parentheses inside, x plus 3 plus x plus 4y. And this is an x plus 3 minus x minus 4y. Now I'm going to add like terms, 2x plus 4y plus 3. And the x's drop out, and I just have 3 minus 4y. That doesn't matter the order that we write that in. Finally, number 18, this is still a difference of two squares. So, big parentheses. First group, I've got, well, let's do the plus minus. Then the x plus y squared, and the 4 is going to go down to be a 2, so this is 2 parentheses x plus y. Plus, and then this is parentheses 2y minus z. And then the other one's identical around that minus sign, 2 times x plus y. And then parentheses 2y minus z. Now we're going to simplify inside the parentheses, so this is going to be 2x plus 2y plus 2y minus z, and this is 2x plus 2y minus 2y plus z. Add your like terms. We have 2x plus 4y minus z, and 2x, the two y's drop out, and so that's 2x plus z.